In this video, we will practice how to calculate protons, electrons, neutrons, and mass number for subatomic particles involving neutral atoms. See my other videos for a more extensive discussion on how to do all the calculations involving subatomic particles. Let's start with the example palladium, Pd, which has a mass of 104. To find the number of protons, we simply look at the periodic table for the atomic number, and we find 46. Since this is a neutral atom, the number of protons equals the number of electrons for 46. To calculate neutrons, we simply subtract the number of protons from the mass number for 58. Therefore, palladium with a mass of 104 has 46 protons, 46 electrons, and 58 neutrons. Next, let's look at sulfur having 16 neutrons. If we look at the periodic table, we will see that sulfur has an atomic number of 16, which means it has 16 protons. Since it's a neutral atom, it also has 16 electrons. If we add the protons plus neutrons, we can obtain the mass number of 32. Therefore, sulfur with 16 neutrons has 16 protons, 16 electrons, and a mass number of 32. Next, let's consider an element that has 48 neutrons and a mass number of 86. If we subtract the difference in the mass number and number of neutrons, we obtain 38 for the number of protons. On the periodic table, 38 protons corresponds to Sr, strontium, as the element. Since this is a neutral atom, the number of protons equals the number of electrons for 38. Consider an element that has 10 protons and 12 neutrons. 10 protons corresponds to neon on the periodic table, based upon its atomic number. Since again the protons equals the number of electrons in neutral atoms, we have 10 electrons. If we add the protons plus the neutrons, we obtain a mass number of 22. For a neutral atom that contains 19 protons and 22 neutrons, we can add the number of protons plus neutrons to obtain a mass number of 41. Since this is a neutral atom, the number of electrons equals the number of protons. And if we look at 19 protons on the periodic table, we will find that it corresponds to an atomic number of 19 for potassium. There you have it. Practice problems for neutral atoms counting protons, electrons, neutrons, and mass number.